Hi, and welcome back to Free Maths Lessons. By the end of this video you should be able to define a surd, know and apply the basic rules of surds, and know how to simplify surds. This is for higher tier only. First, we will look at what surds are. A surd is an irrational square root such as the square roots of 2, 3 and 6. We leave them as it is, as they are more accurate than using their decimal equivalent. This is because surds are irrational, meaning they have an infinite number of decimal places, which means you will have to round at some point. An example is the square root of 2, which starts off as 1.141, and so on. However, these square roots like the square root of 9 or 49 aren't surds because they can be expressed as whole, or rational numbers. We will look at a basic rule for surds. A square root of something multiplied by the same square root, equals the whole number inside the surd. In other words, the square root of a, times the square root of a, is a. Therefore, the square root of 3, multiplied by the square root of 3, is 3, and so on. Another surd rule is that you can collect them, like this. In this case, 3 root 7 means 3 times the square root of 7. Collecting surds is just like algebra. Remember that you can only add surds of the same number. You can also multiply and divide surds directly, even if they aren't the same number. Here are 4 examples, down below. Seen with the previous laws, you may have surds with a multiplier, a whole number before a surd. When multiplying or dividing with them, you treat the whole numbers and surds separately. The first example is 2 root 3 times 4 root 7. We multiply the whole numbers together, and the surds together, to get an answer of 8 root 21. The second example uses similar steps, treating the whole numbers and surds separately. You may also have questions asking to expand brackets. This is similar to algebra once again. To expand the brackets, multiply the outside term with each term inside the bracket. You may even have double brackets to expand, like this. To expand double brackets, remember the acronym, FOIL. F stands for first, multiply the first term of each bracket. O stands for outside, I stands for inside, and L stands for last. This slide will now show a very important rule involving surds. When writing surds, you want the surds to be in the form of a root b, where b has no square number factors, not including 1. In other words, the square roots of 32, 8, 18 and 98, as well as many others, have factors that are square numbers, meaning you can simplify them. Simplifying surds make them easier to calculate with, and simpler to read. Now this slide will show how to simplify surds. We'll use an example, the square root of 8. First, we split the surd into a factor pair, where one of them is a square number. We know that when multiplied back together, you will end up with your original surd. Lastly, we convert the surd with a square number to a whole number. In our example, the square root of 8 becomes 2 root 2. We'll now show a useful use for simplifying surds. Simplifying surds before calculating is a good idea. This is because if you don't, you may end up with very large numbers in surds, which would be harder to simplify. Sometimes, it is the first step to do, especially with addition and subtraction with surds. Here is one example with multiplication. And here is one for addition. You can see that the first surds couldn't be added right away, so they were simplified, which could then be added. Now, try these practice questions based on what we've learned. Remember to simplify your final answer fully. Here are the answers to the questions. Question 1 was a simple simplifying surd question. We split the square root of 108 into a factor pair of 36 and 3, to get 6 root 3. Question 2 was adding surds, simplifying the surds before adding them, simplifying to multiples of root 5, to get a final answer of 9 root 5. Question 3 involved a double bracket. Using FOIL, the order for steps, we came to a final answer of 7 plus 5 root 5. The last question had a single bracket with an outside term. However, the outside term had a large number, which was simplified in my example to 4 root 6. Expanding the brackets, we came to a final answer of 8 root 6 plus 12 root 2. Now you should be able to define a surd, know and apply the basic rules of surds, and simplify surds.